Paper 2 is won or lost on just a few marks. Today we are hacking the exam. We isolated the top 10 most frequent, highest failing IGCSE physics MCQs. These are the exact traps Cambridge uses to drop your grade. Master these 10 and you master the paper. Calculators out, let's score that A star. Log in. Starting from motion. A car accelerates uniformly from rest to 20 meters per second in 5 seconds, then travels at constant speed for 10 seconds. What is the total distance traveled? For that question, sometimes they may give you a graph. Okay, and the graph looks like this. It's going uniformly accelerating and then moving with a constant speed. Okay, so how to work out the total distance traveled is the area under the graph. So you need to work out the area of triangle as well as area of that rectangle. Okay, so for that 1 by 2 times 20 times 5, and for this 20 times 10. So you may work out it as 50 plus 200, and that is 250. So C is your best. Question number 2. Forces and Newton's law. A rocket in deep space, no gravity, no air resistance, fires its engine for 5 seconds, then switches it off. What happens to the rocket's velocity after the engine stops? So the most field response for this is it increases gradually. While actually what happens, like even if it stays on for 5 seconds and then it switches it off, there is no gravity and no air resistance. Remember that thing, there is no resultant force acting on the rocket. So it means that it is still moving with a constant velocity. Here we hold the Newton's first law, which says if there is no resultant force acting on it, it should move with that constant velocity. So option C is again the perfect option. All right. Question number 3, energy. A ball of mass 2 kg moves at 6 meter per second. What is its kinetic energy? And this is pretty easy. You must remember the formula for kinetic energy. Just substitute the values and you may get your response. So this is 36, option C. Sorry. Question number 4, from electrical quantities. Two resistors of 4 ohm and 6 ohm are connected in parallel. What is the combined resistance? Here we get the diagram or circuit diagram for that as well. So if they're connected in parallel, so you must remember the total resistance is, so when you simplify it, you may get 4 into 6 by 4 plus 6, 24 by 10. This is 2.4, and again, C option, right? Moving to question number 5, that's from electromagnetic effects. A wire carrying a current is placed in a magnetic field. The force on the wire is maximum when the angle between the wire and the magnetic field is, all right, the Fleming's left-hand rule. Okay. So here you must remember that force, magnetic field, and current should be 90 degrees to each other. Waves. A wave has a frequency of 500 hertz and wavelength of 0.68 meter. What is its speed? Recall the equation. Just substitute the values, use the calculator, and you may get exact response 340 meter per second. Option C. Question number 7. This is from thermal physics. How much energy is needed to heat 2 kg of water from 20 to 70 degrees Celsius, while the specific heat capacity for the water is 4200 joule per kg degree Celsius? So remember the equation, and the equation is pretty easy. E equals to mc delta T or delta theta. Okay. So what is E? The mass is 2 kg, this is 4200, and this is 70 minus 20. This is the change in temperature. So you calculate it, and this is 420,000 joule. That is B. Now moving toward question number 8, that's from radioactivity. A radioactive sample has a half-life of 3 years. The initial count rate is 800 counts per minute. What will be the count rate after 9 years? First of all, work out how many half-life have been passed. So 9 divided by 3 gives you 3 half-lives, okay? So if initially it was at 800, after first half-life, it will left this after second half-life, and after third half-life, the number of remaining nuclei is 100, and this is 100 counts per minute, option C. Right. Question number 9, light. Which condition is required for total internal reflection? That is very basic question, and it's a very repeated question. Okay. So you should remember there are two conditions. The first one is light must travel from a denser to less denser medium. Okay. Okay. So we are left with only option B. We are not with two options here. The light travels from more dense to less dense medium, and the angle of incidence should be greater than critical angle. And the last question is from again from electric circuits. A lamp operates at 12 volt and carries a current of 2 ampere. What is the power of a lamp? P is equals to IV. That is a simple question, and it gives you 24 watt. All right. 10 questions, total mastery. You now hold the ultimate advantage for paper 2. Do not let Cambridge trick you. Outsmart the paper, crush that like button, subscribe for the paper 4 breakdown, and comment your target grid below. You have got this. See you in the next one.